Hey guys, we are going to take a look at 5.5 notes today. So number one here says to solve this equation, and we're probably going to be using the double angles formula that we've got here. In fact, these double angles always have like a 2u, or it could be 2 theta. In our case, it's a 2x. If it's a plain x, I don't have to use the double angle formula. So let's see which of the ones we're using. This is sine of 2x. So let's see, sine of 2u, I've got an x instead of a u, but this is going to change into 2 sine x cosine x. The beginning part here, nothing to adjust. And if I'm solving for this equation that all equals 0, I'm probably going to factor and set my factors equal to 0. So my GCF, my greatest common factor, looks like a 2 cosine of x. And then I've got 1 plus sine x left. All right, so if I set each of my factors equal to 0, then I get 2 cosine of x equals 0 and 1 plus sine of x equals 0. So if I divide by 2 on both sides, I'm down to cosine of x equals 0. And on my unit circle, cosine is 0 at pi halves and 3 pi halves. That's in one rotation, I should say. And then, let's see, my next equation here, if I subtract the 1 over, okay, and sine is a -1. Again, I'm talking about one rotation. Sine would be a -1 at 3 pi halves. So on my unit circle, if I put these points on my unit circle, pi halves and 3 pi halves, they are half a circle or pi away from each other. So I think I'm going to go with pi halves plus, and this is, I'm going to say plus pi times n. So every n pi. So pi halves plus 1 pi, pi halves plus 2 pi, pi halves plus 3 pi. I keep going around and around a distance of pi each time. Okay, so here's my x. All right, and then, oops, I think I got rid of my little n here. There we go. Number 2 here, use the conditions below to find sine of 2 theta, cosine of 2 theta, and tangent of 2 theta. So I need all 3 trig functions here. I'm probably going to need to figure out where this is on my unit circle. So they said, first of all, you're between 3 pi halves and 2 pi. So I'm basically in the 4th quadrant here. And they also said that cosine of theta, here's my angle theta here, cosine is 5 over 13, which is adjacent over hypotenuse. There's my 5 over 13. So I'm going to do some Pythagorean theorem and find my missing side on the triangle. Looks like b squared equals 144, so my b is a 12. And whenever I take a square root, I get a plus or minus. So when I take the square root of my b squared, square root of 144, a plus or minus, meaning should this y value here be a positive or negative y value? And I think because I'm in the 4th quadrant, I have to have a negative y value, so I'm gonna have a negative 12 for my y value. All right, and because I have all 3 sides of the triangle, now I can find whichever trig functions I want. And this angle, though, this angle is plane theta, not 2 theta. So if they want sine of 2 theta, let's look at the identity we used up here. I need 2 sine of theta cosine theta. Okay. All right, and my sine of theta, so like the y over the hypotenuse here, is going to be a negative 12 over 13. And then the cosine of theta, they actually already gave us the cosine of theta, is 5 over 13. You can also see that on the unit circle triangle that we put together, 5 over 13. Okay, so let's simplify this down to a single fraction. Let's see here. So I'm at a negative 120 over 169. Okay, and that's just my sine of 2 theta. All right, so my cosine of 2 theta, let's look at our identity up here. Cosine of 2 theta, you've got actually 3 different options that you could use for that. They should all come up with the same answer. So maybe I'll pick this one, sure. 1 minus 2, let me rephrase this, cosine of 2 theta is 1 minus 2 sine squared of theta. And we already found the sine. The sine is our negative 12 over 13, or the opposite over hypotenuse, either way. Negative 12 over 13. We needed sine squared. All right, so we have a denominator of 169 again. So I will treat this as 169 over 169 minus, let's see, we've got a 288 over 169, okay. Looks like I'm at a negative 119 over 169. Okay. And then last but not least, we've got the tangent of 2 theta. So here's the identity for that. Up here, you've got to do a 2 tangent of theta over 1 minus tangent squared of theta. So you can see it, okay, 1 minus tangent squared of theta. Okay, as for tangent, tangent is opposite over adjacent. So we haven't used the tangent yet, but we still can get it off of that triangle. I would have 2 times my tangent, negative 12 over 5, over 1 minus the same tangent, negative 12 over 5, squared. It's a little messy. You've got fraction over fraction. So let's go ahead and subtract these. All right, and then I'm going to try and put them into a single fraction here. So I will now multiply by the reciprocal. I'm going to multiply by 25 over a negative 119. Okay. So 5 goes into 25 5 times. So it looks like I'm making, also have a negative times negative, so an overall positive 120 over 119. Okay, so here's my sine, cosine, and tangent of 2 theta. All right, and then number 3 here, rewrite your sine of 3x in terms of sine x. So I think what I'm going to use, based off of these here, I'm going to break it up into, instead of sine of 3x, I'm going to break that up into a sine of 2x plus x is a 3x. All right, so we're going to have to reach out to another identity that we used. So this was, let's see here, pull up my other identities. All right, so here's our identity sheet here. And our sum and difference, there we go. Sum and difference, so the sine of these two things added up, here's on my formula sheet here. So that would be, instead of a u, this is a 2x, and instead of a v, I've got a plain x. So sine of 2x cosine of x. All right, and then plus cosine of, again, my u is the 2x, so cosine of 2x sine of x. Okay, so they want us to rewrite it in terms of sine of plain x. I don't have a 3x anymore, but I still have some 2x's. So let's now break down our sine of 2x again. Here's our formula for sine of 2x. Sine of 2x is going to be 2 sine of x cosine of x. And I still have this other cosine of x. Okay, brought that with it. Now my cosine of 2x, you have 3 different options that you can use here. We used this green one last time. Honestly, they're all equal to each other, so it doesn't really matter. Maybe I'll do the, cosine squared minus sine squared, sure. Now keep in mind, this entire cosine of 2x, that whole thing is multiplied by sine of x. So like I need to put parentheses around it. That whole thing is multiplied by this sine of x. Okay, so I can simplify this down a bit. I've got a couple of cosines multiplied together here. And then I can distribute my sine of x. On this one, I've got a sine x cosine squared x, and then minus sine cubed of x. And then let's see, it looks like I have the same thing here. I can still combine this a bit. So I've got 3 sine x cosine squared of x, and then I've got a minus sine cubed of x. All right. Now again, keep in mind, I'll highlight this. This was the identity I used from my cosine of 2u. If you used a different one, so say I use this one, it would look differently. That doesn't mean it would be equal to what I ended up with this time, but it may look a bit differently if you chose a different one of those identities. Okay. But my goal was to be in terms of sine of x. I think I've got everything down to a plain sine of x except for one thing. Let's see if it, there we go. Let's see, I've got a sine of x cubed, I've got a plain sine of x here. Ooh, I got a cosine of x though. Let's see if we can keep going a little bit further. My cosine squared, if you use the Pythagorean identity, the cosine squared of x is equal to 1 minus sine squared of x. All right, so if I distribute my 3 sine of x, I've got 3 sine of x minus 3 sine minus 3 sine cubed of x, and then minus another sine cubed of x. So I think I can combine these like terms. They both have a sine cube, so I get 3 sine of x, and then minus 4 sine cubed of x. So my final answer, regardless of which of these identities that you chose, my final answer should end up like the answer that we got here. But on your way throughout the work here, if you chose a different identity, it may have looked a bit different as you walk through it. Let's see if this will let me work. Let me erase. Maybe it doesn't let me erase. Okay. Whatever. Okay. So here's our final answer down here. So we're gonna get some more identities. I know, crazy, we have so many identities. This one is the power reducing formulas, and we're gonna rewrite your sine to the 4th of x in terms of the first power of cosines. So it's actually very similar to what we just did up here. We had to rewrite it in terms of like a plain sine x, but you're basically rewriting it. All right, and in this one, because notice I've got sine to the 4th, but these power reducing formulas had to do with a sine squared. So I'm going to rewrite this as a sine squared of x all squared. Like something squared is basically raised to the 4th. Okay, so then that, if I use this identity here, I'm going to get 1 minus cosine of 2x. I'm not using a u, I'm using an x, but same deal, all over 2. So there's that identity. It's squared though. Okay, so that means 1 minus, no, I think I'm going to rewrite it. Instead of dividing by 2, I'm going to rewrite it as a 1/2. My personal preference there. Okay, so the 1/2 times 1/2, that's going to give me a 1/4. But I still have to distribute my 1 minus cosine of 2x. Oops, I missed a 1 minus. It should also be a 1 minus cosine of 2x. Okay. Again, it was squared, so that's why it looks like the same thing multiplied together. If I do my distributing, I'll leave this 1/4 here for a sec. If I do my distributing, I get a 1 minus cosine of 2x, and then I get minus another cosine of 2x, and plus cosine squared of 2x. Okay, combine these here, 1 minus 2 of the cosine 2x's, the cosine squared of 2x. And again, my goal here is to have cosines, which these are all cosines, good, but I want the first powers of the cosines. So I want not a cosine squared, I gotta get rid of that cosine squared. So I'm going to use this identity here for cosine squared. In this case, I don't have cosine squared of u, I have cosine squared of 2x. So whenever I see this u on my identity right now, I'm going to use a 2x for the u. Okay, so 1/4. I still have the 1 minus 2 cosine of 2x. That hasn't really changed. It's this last guy, the cosine squared of 2x, that we are going to use the identity on. And it's going to be a 1 plus cosine of 2 times my 2x. Instead of 2 times u, my u is a 2x, and then all over 2. All right, now I think online they don't like to see it really messy like this. First of all, I've got like the way that fractions are really messy. I think I'm going to factor out my 1/2. So I'm gonna get like a 1/8 here. Basically, I'm multiplying all these guys by 2, and then I'm dividing this by 2. So I'll show you what I mean. I'm going to get a 2 minus 4 cosine of 2x. And then these guys, I have gotten rid of the whole dividing by 2. Okay. So I took care of my fractions. I also have a 2 times 2x here, so a 4x. All right, and I will now combine like terms. I'll combine my positive 2 and positive 1, 3. The rest of these guys, though, they're like as good as they're going to get. I cannot combine a cosine of 2x and a cosine of 4x. There's my final answer. They're all first powers of cosines. All right, next up, they give you some half angle formulas. So find the exact value of 105 degrees. It's probably in the half angle formula section because that's half of something that we are familiar with. So I'm going to treat this as sine of 210 over 2 degrees. So 210 divided by 2 is 105, and 210 is something that we have memorized on the unit circle. So we're going to use this half angle formula. So we've got the sine one, which means I'm going to get a plus or minus on my square root of 1 minus cosine. This is supposed to be cosine of u here, which my u in this case, whatever was being divided by 2, I've got a 210 divided by 2. So my u is 210. 10 degrees. All right, all over 2. All right, and first things first, as far as the whole plus or minus goes, we've got, here. Let's see, we were doing 105 degrees, which on my unit circle, 105, that's like more than 90 degrees, but it's less than 180 degrees. So it's like in this second quadrant. And my sine always has to do with the y values. So I should have a negative x, but a positive y value, meaning that my sine is a positive in this quadrant. So as far as my plus or minus goes, I know it's going to be positive on this square root. And let's see, 210 degrees should be something we memorized. 210 degrees, it is like 30 degrees past 180. Here's my 210 degrees. And the xy point for that is a negative root 3 over 2, negative 1/2. We're looking at the cosine of 210 degrees, and the cosine is always the x value. So my simplification, I've got minus a negative root 3 over 2, and then all divided by 2. Okay. The minus and negative, that's going to turn into overall addition. And then it's not very pretty, but we have like a square root under a square root. I am going to try to simplify this as best I can. I will treat the number 1 as a 2 over 2. And then that is all divided by 2. Very messy, but I'm going to end up getting 2 plus root 3. And then if I have like half of a half, that ends up with a fourth. This is like all over 4. I don't know the square root of that numerator. That is incredibly messy, but the denominator, the 4, I know the square root of 4 is 2. So here is my final answer. All right, and then number 6 here, find all solutions of this equation in the interval 0 to 2 pi. Okay, so first things first, I'm noticing I've got a cosine of x and then a cosine of x over 2. So they're not the same as of right now. I'm going to have to adjust that. So I think I'm going to probably use my cosine of u over 2, like the half angle formula, for this cosine squared of x over 2. All right, so this is going to give me, okay, we'll deal with the plus or minus in a second here. It's going to give me that identity, 1 plus cosine of u over 2, and it is squared. Okay, so there's like my cosine of x over 2 all squared. I got the 2 out front. Left side I haven't really messed with. Okay, so as far as the plus or minus goes, right here, the reason I don't really care about that on this is because it's going to be squared, and like think about positive 3 and negative 3. Positive 3 squared is 9, negative 3 squared, still a 9, so whether it's a positive or a negative, either way, I'm going to get the same thing. So my square root, squared exponent, those are inverses. So those are gone. I'm left with the 1 plus cosine of, oh, u, I shouldn't have a cosine of u because I've got x's in this one, so cosine of x. There we go. 1 plus cosine of x over 2. This actually is looking nice and pretty as far as things canceling out. I already had my square root and my squared exponent. I'm multiplying and dividing by 2. Those are going to divide out. Oh, I can now subtract 1 on each side. All right, all right. Cosine squared of x equals cosine of x. Now, I do not want to divide by cosine on both sides. What I want to do is subtract my cosine. I want this all equal to 0. So if I factor out my cosine, I end up with 2 different factors, and I have to set each of the factors equal to 0. So I will set the plain cosine of x equal to 0, and the other factor, cosine of x minus 1, to 0. All right, so on my unit circle, when cosine equals 0, that's like on x values equaling 0, so that would be up here and down here, so this would be at like pi halves and 3 pi halves. And that is in one rotation, so the 0 to 2 pi section here. Okay. And then let's look at this other equation. If I add the 1 on both sides, sine of x 1, and on my unit circle, cosine, or the x value, is a 1 right over here at 0. And so 0 radians or 2 pi radians, but if I look at the way the interval they told me to go, they want me to go from 0, including the 0. See, it's got the square bracket on the 0, include the 0, but parentheses here do not include the 2 pi. So I'm actually not going to include that 2 pi. I know they're both the same spot on my unit circle, but I'm only including the 0. So that means I have 3 answers here for my x. X equals the 0, the pi halves, and 3 pi halves. There we go. All right, and then all right, product to sum formulas. Okay, so your product to sum formulas we're going to use on number 7 here. Rewrite the product cosine of 5x, sine of 4x as a sum or difference. So again, sum and difference means like addition and subtraction. So I'm going to look at this cosine of something times sine of something. It's like this identity right here, cosine of u times sine of v. And then I will try to plug it into the right side of this formula here. So I will get 1/2, and then here's my brackets, sine of the u plus v, like the 2 angles added together. In our case, the 2 angles were a 5x and a 4x. All right, minus sine of, I have to now subtract the u and the v. So u is the 5x minus the v is the 4x. Here's my u and my v. Let me put some parentheses here. I get sine of, let's see, a 5x plus 4x is a 9x. minus sine of 5x minus 4x is a 1x, so just plain x there. All right, and there's our final answer. All right, so we wrote it as a sum or difference. Actually, I think I might be able to take one more step. As far as a product goes, as far as multiplication goes, I noticed that I do have a little bit of multiplication here. So if all I want is a sum or difference, maybe they want us to distribute that 1/2. Honestly, I think these are probably both acceptable. I would be okay with either of these answers. In fact, I think the website would be okay with either of those. All right, and then we've got sum to product formulas, lots of formulas. There's a formula sheet now posted on Canvas, so you guys can check that out. So the sum to product formula says find the exact value of cosine of 195 degrees plus cosine of 105 degrees. I'm adding two separate cosines, so I'm thinking probably going to go with adding two separate cosines. I'm going to go with this identity. And then that would mean cosine of u, the u is a 195, plus cosine of v, the v is 105, and let's plug it into the other side of the equation. So this will equal 2 times cosine of the u plus v over 2 times the cosine of the u minus the v over 2. Okay. So let's see, 195 plus 105, where am I at here? 300 divided by 2, so 150. 150 degrees here. Cosine of, let's see, 195 minus 105, so like 90 divided by 2 is 45, so 45 degrees. These should be spots that we had memorized on the unit circle. So let's take a look. 45 degrees is in the first quadrant right here. That was the point root 2 over 2. Let's see if I'll write this. Root 2 over 2, there we go. And another root 2 over 2. 150 degrees, that's like 30 degrees short of 180. So that's this guy down here. This was a negative root 3 over 2, 1/2 point. So if we had our unit circle memorized, we can now find the cosine, which is the x value of each of these. So here's our x values. We've got cosine of 150 was a negative root 3 over 2, and the cosine of 45 was a root 2 over 2. And we still have this 2 in front. Let's see, if I divide that out, I'm going to end up with a negative, and root 3 times root 2 would be like a root 6 over 2. There is my exact value that they were going for. All right, and the last one. Solve this sine of 5x plus sine of 3x. Excuse me. And so because it's equal to 0, that actually makes me think that's probably better that way. I want it equal to 0. Usually that's when I do like factoring and stuff. I don't think I can factor anything out though. My sine of 5x and my sine of 3x, they both are sines, but I can't really factor that out. I think I'm going to have to go use my sum to product. There we go. That's probably why it's in this section here. Sum to product. In fact, this is a sine of 5x plus sine of 3x. It's a sine plus a sine, so I'm probably in this top formula here. A sine plus a sine, where, let's see, sine of u comes first, plus sine of v comes second. So my u is the 5x, and the v is the 3x. All right, so I need 2 times sine of u plus v. Let's see here. And my u is a 5x plus the v, which is a 3x, all over 2. And then cosine of the u, which is a 5x, minus the v, which is 3x, all over 2. Okay, this is still equal to 0. That has not changed. I'm going to zoom in here a little bit. So 2 times sine of, let's see, 5x plus 3x is an 8x over 2, and cosine of 2x over 2 all equals 0. So I've got 2 times the sine of 4x times the cosine of plane x equals 0. Okay, the reason we wanted it to turn into a product, into this multiplication, is because this is like what we usually do with factors. You set your factors equal to 0. So 2 never equals 0. I'm not going to worry about that. But this sine of 4x, that could equal 0. And my cosine of x, that could equal 0. Okay. So let's take a look at this real quick. We've got sine hits 0 on my unit circle here at 0 and at pi, but that's when like sine of plane x equals 0, right? But I don't have sine of plane x, I have sine of 4x. So my point is this is going to happen like 4 times as often. So it's actually, let's consider this. I'm going to break that into 4 equal sections here. So I'll go to this line. Maybe I'll do this another color. Okay. So here's like 1, 2, 3, 4 different sections instead of what was our one section. So these would be at 0, at, this is pi fourths, plane pi, this is 3 pi and pi. So let's check this out. Does this work on all those points? If I put in a 0, sine of 0 is 0, that's true. Okay, if I put in the pi fourths, 4 times pi fourths is plane pi, and sine of pi is still 0. Good. So pi fourths works. Pi. Sine of 4 pi. That would be like, here's my 1 pi, 2 pi is a full circle, 3 pi, 4 pi would land me right here again, and sine, the y value there, is still 0, so that works. Same thing for the 3 pi fourths. You guys are probably getting the hang of this. 3 pi fourths times 4 is a 3 pi. So that would be, you know, there's my 1 pi, there's 2 pi full circle, 3 pi. And I still landed in the same spot. Like with a y value of 0, so my sine is still 0 there. And if I use the plane pi in here, sine of 4 pi. Oh, sorry, this was off. This was pi halves. The pi halves in here does work though. Pi halves times 4, that's 2 pi. And if I go 1, 2 pi, it still has a y value of 0. At the pi here, if I plug that in, 4 pi, that would go 1, 2, 3. There we go. 1, 2, 3, 4 pi actually still lands on one of those spots I was going for with a y value of 0. In fact, if I keep going at this pattern, then I've got 5 pi fourths. All right, and 3 pi halves are down here. 7 pi fourths. All those spots end up making this work out. So I'm going to put those in my list here, what x equals. 0, pi fourths, pi halves, 3 pi fourths, very long list here. Pi, 5 pi fourths, 3 pi halves, and 7 pi fourths. Now, if they wanted me to solve, for an entire, okay, let me reword this. If they tell me a specific interval, like they've done up here, where they said like from 0 to 2 pi, if you know you only want one rotation, then great. These answers that I have right here, those were within one rotation. I didn't see them write anything about 0 to 2 pi though. I didn't see just a single rotation. So this looks like it would be like a 0 plus, I'm adding pi fourths any number of times, so pi fourths times n. I really don't need to put plus 0, so I'll just put x equals pi fourths times n. Okay, so these are the solutions to this first equation. Let's look at this last one here. Cosine of x equals 0, which on my unit circle, cosine the x value is 0. See right here and right here, which is at pi halves and 3 pi halves, which this didn't say, 2x, 3x, 4x, that it was just a cosine of x, so I don't have to adjust anything like I did on the sine, because sine was 4x. This would just be a pi halves, and a 3 pi would be like, I would add a pi over and over and over again. But I think those have already been added on my list, and as many times as I go around the unit circle, I'm still going to hit those points. So I think those are taken care of in my list of points that I already have. So my final answer is just the x equals pi fourths times n. All right, there we go.